Good day, everyone, and welcome to our week 6 of our third quarter. Sorry if I cannot be with you in our class today because I am attending a seminar for the upcoming election. But I will leave activities on our group chat that you need to answer and then send me your answer. We will do the same routine. After you send your answer, I will send back the answer key and then check your answer and then send back the score so that it will be recorded. So for this time, we will be dealing with light as part of our week 6. Before we start with our discussion, I have here questions that will be thrown also at the end of our discussion. Let's start with the first one. So what you only need to do is to choose the letter of the correct answer. Question number 1. Which of the following statements is true about wavelength of light? A. The shorter the wavelength, the lower the energy of light. B. The longer the wavelength, the lower the energy of light. C. The longer the wavelength, the energy is stable. And D. The shorter the wavelength, the energy is at rest. Question number 2. What color of light has the lowest energy? A. Blue. B. Red. C. Violet. D. Green. Question number 3. What is the evidence that light travels in a straight line? A. Hologram. B. Rainbow. C. Mirage. D. Shadow. Question number 4. What will happen to light when it strikes a smooth surface? A. Light will bounce back. B. Light will be scattered. C. Light will bend. And D. Light will be absorbed. Question number 5. Light intensity decreases as the square of the distance increases from the source. If you double the distance from the source, what will happen to the intensity of light? A. 1/8 of its original value. B. 1/2 of its original value. C. 1/4 of its original value. And D. 1/9 of its original value. Question number 6. Which color of light has the highest frequency? A. Blue. B. Red. C. Violet. D. Green. Question number 7. Cyan minus yellow equals blank. A. Red. B. Blue. C. Violet. D. Green. Question number 8. Color is a property of light which depends entirely on A. Medium. B. Power use. C. Source. D. Frequency. Question number 9. The color of an opaque object depends on blank. A. The kind of light it emits. B. The amount of light it reflects. C. The kind of light it transmits. And D. The amount of light it absorbs and reflects. And lastly, the spreading of colors by a prism. A. Diffraction. B. Dispersion. C. Reflection. D. Refraction. These questions, you can find the answer to these questions as you listen or as we go on with the discussion. So for this time, we will be dealing with the topic light. Light is an example of a wave. Here's an example of the wave that we have discussed last time. For us to continue studying light, we need to have a recap of the parts of the wave that we have discussed last time. Again, what do you call this part of the wave? If your answer is crest, then you are correct, since it pointed on the highest part of the wave. How about this one? If your answer is trough, then you are correct. These 2 points that touches the equilibrium or rest position of the wave are what we call as nodes. And the distance between two crests or two troughs is what we call as wavelength. And the distance from the crest or the trough from the rest position is what we call as the amplitude. So these are the parts of the wave that you will encounter as we go on with the discussion of lights. Light, being one of energy, is also an example of a wave and also a particle. The question is, where does light came from? Our ultimate source of light is the sun. Aside from the sun, what else does light came from, or where else does light came from? It came from bonfire, thunder, flashlight, lamp, firefly, candle, the monitor of the computer, and neon lights. The question is, how can we classify these sources of light? Sources of light can be classified into two, that can either be natural or man-made. Of course, the difference between natural and man-made, one is made by nature and the other one is being made by human. Here's an example. Bonfire, is it natural or man-made? If your answer is man-made, then you are correct. Lightning is an example of a natural source of light. Flashlight is also an example of a man-made or artificial sources of light. Lampshade is also artificial or man-made. The monitor of the computer is also an example of a man-made or artificial sources of light. Firefly is an example of a natural source of light. Fireflies can make their own light through the process called bioluminescence. They have chemicals in their body which can produce light. Candle is also an example of a man-made or artificial source of light. We also have the last one. We have the neon light, which is also an example of the artificial source of light. And of course, we have the most natural source and the ultimate source of light, which is sun. Now, are these examples of light source? The first one is moon. The answer is not. Water? Not also. The same thing as mirror. Even though they have or they produce this light, what they only do is they only reflect the light that hits them. They doesn't produce their own light. So what they only do is to reflect the light that hits the surface, just like for a mirror. When you put flashlight in the in front of the mirror, the tendency is the light from the flashlight will be bounced back. The mirror does not create its own light. It only reflects the light that comes from the mirror. Now, objects that can produce their own light are what we call as luminous. Objects that doesn't produce their own light are non-luminous. Let us classify these 10 objects whether they are luminous or not. First one, sun. Is it luminous or non-luminous? If your answer is luminous, then you are correct. Chair? Non-luminous, since chair doesn't create its own light. Candle, luminous since it creates light. Lamp is also luminous. Shoes is non-luminous. Flashlight, luminous. Mirror, non-luminous. Firefly, luminous. Glass, non-luminous. Moon is also non-luminous. From our examples here, you can say that non-luminous materials only reflects light. The light that you can see from a source differs from the how far it is from the source. So let's say, for example, we have here a bulb and the distance from the objects that are put at various distance from the bulb. So here's the first one. The first is located 1 meter from the bulb. The second object is located 2 meters from the bulb. And the other one is 3 meters from the bulb. So if an object is located at 1 meter from the bulb, the light intensity of the object is 1. If the object is located at 2 meters, the light intensity becomes 1/4. Why does it happen? Because light becomes or decreases by the square of the distance, or as you go farther from the light source, the light intensity decreases. Habang mas lumalayo ka sa light source, mas humihina ang light, ang intensity ng light. Meaning, from 1, 2, and 3, the brightest is number 1, followed by number 2, and the dimmer or the dim object is at number 3 or at distance number 3. Habang mas lumalayo ka, mas nagiging dim yung liwanag. The closer you are to the light, the brighter the object is. Why? Kasi kumakalat ang liwanag. So from this example, from this part, nakita niyo liwanag is concentrated on this area only. When you go further, the light now should cover up to 4 squares. And then as you go further, it covers 9 squares. So the intensity of light lessens as you go farther from the source. And then, the big question is light a wave or a particle? Based from the particle theory of light by Sir Isaac Newton, he says that light is a particle. It is because he made the corpuscular theory of light. From this, there are two properties of light that can be explained. The first one is reflection and dispersion. So this doesn't happen when light is a wave. Sabi niya, ang light daw dito ay particle. Here's an example of how Isaac Newton explains that light is a particle. Kapag ang light daw ay parang beams of light, this light moves in straight line, and then it hits an object, ang light daw ay hindi nagbe-bend. That's why it created shadow. So kung nandun galing yung liwanag, it creates a shadow over here. The shadow that is created by an object proves that light travels in a straight line. Light travels in a straight line. That is based from Isaac Newton. But here comes another scientist. We have Christian Huygens. Christian Huygens believed that light is a wave. That's why he has this wave theory of light. So for him, light creates as a wave because he believes that when two waves or two light waves interact, they cancel each other. And that is what we call as diffraction and interference, meaning there are two waves that either reinforce or cancels each other. And also, He says that light is an example of a wave because light bends. And the bending of light between two medium is what we call as refraction. Lumiliko daw ang liwanag. That is based from Christian Huygens. If light is a wave, what kind of wave it is? A new observation by Thomas Young proves that light is both particle and wave. If it is both particle and wave, ano talaga siya? Since light is a wave, just like what I mentioned a while ago, what kind of wave it is? Another scientist studies light, and that is James Clerk Maxwell. From his discovery, light is an electromagnetic wave, meaning it produces both electric and magnetic field, and it can travel in a vacuum. Remember the electromagnetic spectrum that we have discussed last time. We have, from the electromagnetic spectrum, we have different electromagnetic waves such as radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma. From the whole electromagnetic spectrum, only one electromagnetic wave is visible to human eye, and that is the visible light. The visible light can be separated also into 7, and that is what we call as the Rayleigh wave, or the red, orange, yellow, blue, indigo, and violet. So, light can be separated into 7 different colors. Now, for us to know whether you understand our lesson, I have here 5 questions. Tell me whether it is true or false. First, light is both wave and particle in nature. If your answer is true, then you are correct. Light travels in a straight line. This is true. What is the proof that light travels in a straight line? It is the formation of shadow. Isaac Newton believes that light is a wave. This is false. Isaac Newton believes that light is a particle. Christian Huygens believes that light is a particle. That is also false. Christian Huygens believes that light is a wave. James Clerk Maxwell proposed the electromagnetic theory of light. This is true. James Clerk Maxwell believes that light is an example of an electromagnetic wave. Since light, from what I mentioned a while ago, is the only electromagnetic wave that is visible to human eye, light can be separated into 7 different colors. We have red, orange, yellow, green, blue, indigo, and violet, or the Rayleigh wave. The intensity of light differs by means of their frequency and wavelength. So by merely looking at the diagram here is color red. So red has a frequency of 460 terahertz and a wavelength of 650. Orange has a frequency of 510 and a wavelength of 590. Yellow has a frequency of 525 and a wavelength of 570. The same for the other colors. Looking at the different colors, you will notice that violet has the smallest wavelength and the red has the largest wavelength. The photon energy signifies the energy level or the energy capacity of each color. By looking at this one, we can say that among the 7 different colors, violet has the highest energy. Take a look at the frequency, the wavelength, and the energy. The greater the frequency, the greater the energy. The lesser the wavelength, the greater the energy. The greater the frequency, the lesser the wavelength. Meaning, frequency and wavelength are inversely proportional. Kapag tumaas yung isa, bababa yung isa. Now, since we are talking of colors, colors can be added or subtracted. Based from this Venn diagram, white is a combination of all the colors. That is a combination of cyan, magenta, and yellow. While yellow is the result of the combination of color green and color red. Red is a combination of colors yellow and magenta. And then blue is a combination of colors cyan and magenta. So that is adding colors. So when you add color green and color red, you will come up with color yellow. And when you combine all these colors, you will produce color white. Why? So hindi naman pwede mangyari yan. When you add all the colors, you will come up with with white. This is true because when you look at the color of sunlight and you use prism, you will see that light can be separated into different colors. One example of this is rainbow. The light that comes from the sun is color white. And then it is being dispersed by the raindrops of water, and then 7 colors appear. That means when you add all the 7 colors, you will still come up with white. The same is true in subtracting colors. If you have color yellow and then you remove color red, you will have color green. Same as cyan. When you subtract blue on cyan, you will have green. When you subtract all the colors, you will come up with black. How come that we have color yellow, color green, cyan, blue, magenta, and red, when light is only color white? The color of an object depends on the color that it reflects. Meaning, if you have red rose, that means all the other colors are being absorbed and the one that is being reflected is only the color red. That's why the roses appears red, or the rose appears red. If you have green leaf, all the other colors are being absorbed and it only reflects the green color. That is how object appears with color. Now, let us identify the resulting color. If we add green and blue, we will come up with cyan. If we add blue and red, we will come up with magenta. If we have add red and green, we will come up with the color. Sorry, this is typographical error. And then when we add red, green, and blue, we will have black. Okay? These are the properties of wave that can be observed when it strikes an object. When the wave passes through an object, this is what we wave can pass through an object if that is transparent. Wave can also be reflected by an object, and that is reflection. Wave can also be scattered, that is dispersion. And wave can also be absorbed, and wave can also be refracted. Okay? These are the properties of light that you need to know. Reflection refers to the bouncing back of light wave as it strikes an opaque material. When we say opaque material, these are materials that doesn't absorb light or does not allow light to pass through, rather. If an object has a color, that means it absorbs light and some of the lights are being reflected. When that is an opaque material, it doesn't allow light to pass through. An example of this is mirror. When you put flashlight in front of the mirror, the light is being reflected. Why? Because mirrors are example of opaque material. Wall is an example of an opaque material. Refraction refers to the bending of light waves as it passes through different medium. Different medium meaning different material. Let's say, for example, we have a pencil that looks broken when you dip it in water because light travels into different medium there. First is water, first is air and then water. So the difference between the medium makes light looks like it bends or make the pencil looks like it is bended, but actually it is the light that bends. That is what we call as reflection. Dispersion refers to the separation of light into different colors. This is the reason why we have rainbows. When white light strikes a prism, 7 different colors are formed. Diffraction refers to the bending of light waves along the boundaries. Example of this is when you look at the light that passed through the spaces between your finger. When you put your hand in front of a light source, say for example fluorescent lamp, and you look at the spaces between them, you will notice that light bends or light passes through the space between the spaces of your finger. Interference refers to the superpositioning of light waves. Example of this is the formation of hologram. Okay? So these are the properties of light that you need to know. Now, I want you to identify on what property of light is being described here. First one, the bouncing back of light waves as it strikes an opaque material. If your answer is reflection, then you're correct. Bending of light waves as it passes to two different medium. This is refraction. And then the separation of light into different colors. The reason why we have rainbow. If your answer is dispersion, you are correct. The bending of light wave along boundaries. This is diffraction. And the superpositioning of light waves is what we call as interference. Okay? Now, going back to the question that I've thrown before our discussion, the first question is, which of the following statement is true about wavelength of light? A. The shorter the wavelength, the lower the energy of light. B. The longer the wavelength, the lower the energy of light. C. The longer the wavelength, the energy is stable. And D. The shorter the wavelength, the energy is at rest. From our example a while ago, the longer the wavelength, the lower the energy of light. Because the lower the wavelength, the longer the wavelength, the lower the frequency, the lower the energy. Since energy is directly proportional to frequency and inversely proportional to wavelength. And then, what color of light has the lowest energy? If your answer is red, then you are correct. Since red has the longest wavelength, it has the lesser or the least energy. What is the evidence that light travels in a straight line? From what I've mentioned a while ago, what should be the answer for question number 3? Is it hologram, rainbow, mirage, or shadow? If your answer is shadow, then you are correct. Question number 4. What will happen to light when it strikes a smooth surface? A. Light will bounce back. B. Light will be scattered. C. Light will bend. And D. Light will be absorbed. If your answer is light will bounce back, then you are correct. As light hits a smooth surface, light will be reflected. Some of the lights will be absorbed and some will be reflected. Depends on the what color is being reflected, on what color the object will appear. If it reflects blue color, then the object will appear blue. Question number 5. Light intensity decreases as the square of the distance increases from the source. If you double the distance from the source, what will happen to the light intensity? A. 1/8 of its original value. B. 1/2 of its original value. C. 1/4 of its original value. And D. 1/9 of its original value. If you double the distance, what will happen to the intensity of light? The answer here is, if your answer is 1/4 of its original value, then you are correct. Because light intensity decreases by square of distance. Since the distance is doubled, so we have 1 over 2 squared, and 2 squared is 4, so that will be 1/4 of its original value. If the light is 1, then the light intensity would be lessened to 1/4. And then, what color of light has the highest frequency? Blue, red, violet, or green? If your answer is violet, then you are correct. Since violet has the highest frequency, it has the highest energy, and it has the least or the lowest wavelength. Cyan minus yellow equals A red, B blue, C violet, and then D green. We have A red. Color is a property of light which depends entirely on A medium, C source, D power use, and D frequency. If your answer is frequency, then you're correct. The color depends on frequency. The longest among the color, or the longest frequency, or the greatest frequency among the color is violet, and the least one is red. And then number 9, the color of an opaque object depends on blank. A. The kind of light it emits. B. The amount of light it reflects. C. The kind of light it transmits. And D. The amount of light it absorbs and reflects. If your answer is letter D, then you are correct. On how much light is being absorbed and reflected. If it reflects color green, then the object would appear green, especially if it is an opaque object. And last number, the spreading of colors by a prism. A. Diffraction. B. Dispersion. C. Reflection. D. Refraction. If your answer is dispersion, then you are correct. So that's all for today. And answer the activities that I sent on our group chat. Again, write your answer on a piece of paper, take a picture of it, and then send it to me. And then I'll send back the answer key, check your own paper, and then send your score to me so that it will be recorded. Remember that honesty is the best policy. You will be the one who will check your own paper, and no one sees whether you commit or when you alter your score or alter your answers or not. And that's all for today. So good day everyone, and keep safe.